Hello, my name is Artem Vasilov and I am a high school student from Dnipro, Ukraine. I want to present the video for my project called Application of the Laws of Illumination. Photometry is a section of optics which focuses on the measurement of light in terms of the sensitivity of a human eye. Several modern problems can be solved by using the methods and formulas of photometry. This is why my project was created. It consists of two parts, experimental and practical. The topic of the first part is verifying the inverse square law of illuminance by means of an experiment. After going through the stages of creation of an experimental setup, measurement, statistical processing of the results, and creation of a graph, this law was confirmed successfully. The aim of the second section is finding the optimal placement of the lights along the rods in terms of reducing the illumination swings. Now let's focus on this one, as it has a valid practical relevance and novelty. Road illumination is proved to increase the attentiveness of drivers and pedestrians, and therefore significantly reduce the number of road accidents. Despite the fact that a huge part of the roads in many countries is still not fully illuminated, and in many places there is not even a full-fledged road surface, we should already be concerned about the subsequent problems. Even if driving at night on a well-lit road, eye strain and tiredness may result from the illumination contrast. This means that the luminance right under the light poles and exactly between the neighboring lights differ dramatically. The efficient way to deal with the illumination swings is to bring the lights closer together. However, the closer we move the lights, the lesser the contrast becomes, so it is minimal only when the lights are back to each other. Given the need for saving resources, my task was to determine the contingent equilibrium between the slight contrast and low material costs. This goal could be reached by making the graphs of the values that designate the swings of illumination, and for this I've had to take these steps. Finding the illuminance function from the coordinate in the simple case of a straight rod model, finding the dependencies of the values that designate the illumination swings in the parameter k, which is the ratio of the distance between the adjacent lights and the height of their poles, making the graphs and finding the answer for the simplest case, considering other typical models and making conclusions. Thus, it was found that in cases of straight and smooth curvilinear roads, the parameter k should be approximately equal to 1.5, and on road sections with heavy traffic, steep turns and sharp relief drops, as well as on remote lanes of multi-lane roads, the illumination swings do not make a significant contribution, and it is only necessary to maintain a sufficient value of illuminance. As a result of the project, the tasks of the research were fulfilled, and directions for further investigation were proposed. The results regarding the placement of the road lights can be suggested for adaptation and application in reality. That's it for my video. Thanks a lot for your attention.